Hello everyone, and welcome back to a new video in our modeling, analysis and design of reinforced concrete building structures. In this video we are going to attempt to define the wind loads of the structure. Please notice that Autodesk Robot has two possibilities to define the wind load on the structure. One of them is to go to loads on wind load simulation, generating a CFD simulation. In this case, Autodesk Robot will attempt to do a computational fluid dynamics simulation in which it simulates a wind tunnel attacking the structure and providing the pressures based on this wind tunnel simulation. The other option is to do the analog option, which is basically to pre-calculate the loads outside and then apply them on claddings on Autodesk Robot. I am going to choose the latter, applying claddings in the structure. With that being said, I hope you enjoy, so sit back, relax, and enjoy the show. Okay, so before I start, I want to first of all thank all my channel members for the support of the channel, and I want to give a shout out to two of my channel members whose discussions in our community tab really enlightened me a lot. First of all, I want to shout out Engineer Ali Omar, who is a member of this channel, and he actually pointed out that the CFD analysis of Autodesk Robot is really accurate, and I think he did a comparative analysis basically stating that yes, the computational fluid dynamics that is being used in Robot is as accurate as it gets, and it should be used. The second channel member I want to shout out here is our dear channel member Yashiv, who actually suggested to just simply use claddings and apply the pressure, calculate the pressure by, old-fashioned way, and just apply them on Autodesk Robot via claddings and loadings. And I actually agree with both, and I want to thank them very much for their contribution to the channel. Now, I'm going to choose to use claddings here. I want to mention something very quickly here, is that if you want to apply a CFD analysis, then it's very important that you should apply claddings or some sort of planar element here. I think that without having a planar element here, it would not register a wall, and it would basically apply the CFD on the beams only. So that's my take on it. However, I'm not going to do this. I have a video speaking about the simulation of robots, wind simulation, which I will link in top right. And also I have another video of wind loads where a robot is able to calculate the pressures himself, but this has a very limited application. I'll just again link it on the top right. So without further ado, let's get into it. Now our dear channel editor is going to, of course, have a lot of editing to do today, because the process of drawing the claddings is time consuming, and there is nothing I want to say here, so other than just drawing the claddings. So in that case, I think the editor is going to speed up the video, and once we finish doing the claddings, we can basically talk about applying the wind loads. So sit tight and enjoy a sped up version of my suffering via drawing the claddings. One thing I want to mention here very quickly is that you have the ability, like if things go really haywire and you are unable to draw, it's able to take part of the structure and open a new window for it. You can basically just select the part of the structure you want, like for example this, and then you can click here, which is basically not save substructure. I don't want to save a part of it. I want to edit a part of it. So if you click edit on new window, it will open a new window with the substructure you have selected. And if you select save substructure, in that case, you would save only this part of the entire structure. So I thought this is a nice thing I want to share with you, because it will speed up my ability to model, especially because there are so many other things. Notice this is just a substructure. Like, let me show you. If you, for example, apply a cladding here, if you go to geometry, claddings, and just do a cladding here very simply, just contour and draw yourself a cladding like this, and then basically finish. There we go. And then there's a cladding here. Of course, if you close or exit now, then the cladding is on the entire structure. And if you see here, it's already drawn. So I thought this is there it is. You can see it maybe here. There we go. So this is a cool feature in Robot. I somehow missed speaking about this, but it actually helps you somehow separate the drawing. If you want to separate and try to focus on one part of the structure, you could even focus on an internal part of the structure, given that you select it. Basically, whatever you select, you can ask Robot to focus on it. You can even see that Robot somehow is faster in rendering now, because it only renders part of the structure, not the entire structure. So back to our drawing board. Okay, so I applied the wind loads on the right structure. I did not on the left structure. I'm not really proud of the method I used. It's like a hacked method where you just apply the loads, but that's the best I could think of. Because I'm trying to keep it practically here. Of course, CFD is a scientific thing, so I might cover it in a different video, maybe even a different series, but I think I have applied the wind loads successfully. Notice that what I have done is only one part of a two-parter because there are multiple cases in the code, and also you have to apply it like you need to make multiple wind load cases. Here I have applied wind X, wind X positive, wind Y positive. Of course, you have to apply wind X negative, wind Y negative, and so on. And this is basically a time sink. This is a time-consuming effort, but well, it is what it is. A calculation just to check. I would be surprised if it does work. Okay, it doesn't work. I'm going to keep it real. I'm going to try to, after doing this, I'm going to try to troubleshoot it right now so that you can basically see what the problem is. Now, for the isolated nodes, I don't care. There are some errors I have covered in previous videos, but for the overlapped panels, that's a no-no, as well as members without properties. That's an odd thing, so I will check out exactly what that is. Of course, I need to wait until it finishes, so let's take a look why we have errors. In the Civil Engineering Essentials channel, I try to keep everything real. If I mess up, I say, hey, I messed up, and I try to show you how you would fix that mess up. Of course, it would take time, but at least let's go investigation mode. It's like, okay, section not default. Wait, what? That's odd. I think I am really surprised. That's a bunch of errors. Okay. Now, section not defined, that should not be because I'm pretty sure I defined all the sections. So let's go one after another. Member without property. I click on it. It will show me which member is without property. It doesn't. That's a new thing. Or does it? It doesn't. Which member is without property? Okay, it says here 1, 2, 4, 3. What do you mean by 1, 2, 4, 3? And what's the section not defined for member 1, 2, 4, 3? Where is this 1, 2, 4, 3? I cannot see it. Is it hallucinating? I don't think it does. Panel. Overlap panel? Oh, yeah, okay, fine. That is something I can fix. This is one of the those are the claddings I added. It says my claddings are overlapping, which is of course a big no-no. It seems my cladding is overlapping with what exactly? Let me see. Let's zoom in and try to understand what exactly is overlapping. Let's take a look. I don't see an overlap. Are you sure about that? And it's a mesh. It's been meshed. So where exactly is the overlap? I cannot see it. Fine, okay, let's take a look. Isolated node, I don't care. That's basically some node that is not connected to the structure. I can just ignore it. Faces without assigned thickness. Oh, yeah, okay, fine, that's the problem. Because it asks me to apply loads in the Y. Because I have not applied loads in the Y yet, it tells you that there's an error. Fine. So this you can ignore. This faces the object without assigned thickness. You can ignore because it somehow freaks out because those claddings don't have loads. Because in the Y, I need still to apply the loads in the Y. I only applied the loads in the X, and I will have to apply the loads in the Y. So that's the problem. Incoherent mesh on edges. Which edges are he talking about? Okay, there they are. Those seem the incoherent meshes. Let me just check. That's something you cannot ignore. Okay, what's exactly happening here? Let's see. It is coherent. I don't see an incoherency. Let me check. I mean, it is coherent. Is he hallucinating? It is pretty much coherent. It's coherent because you can see that the edges are actually the same. Like there is no node on edge. It's perfectly coherent. I don't know why he's hating. Like I have no issue with this. But we will see about that. Okay, cohesion of calculation model has been provided by the kinematic. Okay, fine. He's saying that here he had to apply. Robot thinks that this is an incoherent edge, and he then fixed that by kinematic constraints, by basically saying that, okay, this incoherent mesh is going to be constrained together, like they are going to move as one unit. Let me switch on the node numbers. to see if he defined multiple nodes. Yeah, okay, I see. Yes. He fixed that by defining multiple nodes. Let me show you what I mean. Let's remove this node thing. I believe this error walkthrough is as important as just modeling the thing. Okay, so he's saying here I have incoherent mesh. That is what he's claiming now. I'm gonna zoom in, and I think I know what he did. I think when he was trying to mesh, he was unable to mesh cleanly, so it seems he defined multiple nodes here. It seems. And he connected them with a kinematic constraint to let them move together as a unit. Let's take a look. There should be multiple numbers now popping up here. Okay, my computer is struggling. That's just, there we go. How many nodes are there? Are there 2 nodes? I think I can see 2 nodes here. Let me remove the node numbers because my computer has frozen and this is not a good sign. Incoherent mesh is because Robot was unable to mesh this big chunk of a mess. So it basically just apply the constraint. Now I selected, of course, the frame rate is down. There's a YouTube channel called Let's Game It Out. His name is Josh. And one of the things he does is he tries to kill the frame rate. So basically we are successful in killing the frame rate of the software. I can't work like this. I can't work like this. I just have to zoom out. But okay, I just can say that that's no problem because I saw the edges. My finite element method senses are not tingling. It's okay. And he basically seems to have defined multiple nodes and fixed that by applying kinematic constraints. So good for him, no problem. This is something we can ignore. That's something fine. Now, the defined on a story different from another one, that's not a problem. This means that one of the elements is defined in multiple stories instead of one. So he seems to be angry that, hey, a member should be defined in one story. Why is it extending? That's okay, because our stories are haphazardly. Our stories are defined based on the right structure, but if you remember in the beginning of our series, the left structure has different story heights. That's not a problem. Okay, element defined, we have said this. Element not assigned to any story, that's also not a problem. He's basically telling you that there is a member that has not been assigned any story, which is a big problem for him. For us, it's not a problem. And finally, section not defined for member 143. 1243. Okay, where is this 1243? Let's just click on it and see where it is. This has no section. That's really odd. I'm pretty sure I have applied a section for that. Okay, so member without properties is still the same thing, right? Let's just check. Okay, I need to close this. This is just impossible to work with. Okay, we are back in business. It was 1243. Let's see, 1243, enter. And let's take a look here. It is a member, fine. It is a member, and it's a reinforced concrete beam. And it's a beam element. Okay, where is its section? Wait, what? There is no section. That is really odd. I just don't believe it. Okay, let me just separate it. Edit in your window. So it's that thing, right? Okay, let's open the section. Indeed, there is no section. That is, I think that's from our ramp, it seems. Let's just exit. It should be here, right? Let me open. Wait, what? I lost it. Where was it? Is this 1243? Let's just remove everything and select 1243 and hit the enter key. Okay, to see it, I'll give it a ridiculously big section now. Let's give it something very odd. Let's give it a... Do I have ridiculous big sections? Let's give it the biggest section I have, this one, and apply that. I cannot see it, so I want to see it by giving it a big section and opening the sections. And, there it is. That's the one, right? Strange. Okay, this is the beam. Fine, that's the beam. Okay, so I think that's the problem. I don't know why it has no section, but it is what it is, I guess. I have no idea why it doesn't have a section. I have no answer for that. You know what? I don't even think I need it. Although, on second thought, I think I should need a beam here. Just delete it. Oh, I think I know what happened. I think I know what happened. Look, This is a pitfall everybody can fall in it. When you draw a beam, let me just show you something very stupid in Robot. When you draw a beam like this, here is a beam, right? We have drawn a beam. It's 100% perfect. It has section, it has everything. Now, sometimes when you Control Z, it will undo the section, but not undo the drawing of the beam. Sometimes. Let me just show you. That's a bug from Robot 2010. See, I just undid, and it threw away the section. It did not throw away the beam. You have to undo twice to throw away the beam. And there is a reason behind that. The reason behind that is that Robot, I told you, I program my own finite element software. This window is a lie. When you draw a beam, you think you are drawing a beam. What you are actually doing is you are actually, first of all, drawing a line, and then in a second step, you are applying a section. So when I think I know what happened here. I think I drew a line and then I Control Z'd, and the problem is that I was unable to detect the new line drawn here because there is an edge. Okay, fine. I think now everything is fine. So yeah, I think we have applied our wind load. At least I've showed you the taste of it. Now there are two topics remaining here. Of course, I need to fix my model. That's something I will do off screen. You know the error, there is overlapping panels, and that's something I can just easily delete the panel and redraw it. But the error of member without properties, that was a sneaky error. I think I've explained it to you and you know what happened. What remains now is talking about the foundation and maybe give some slight advice about how to actually size your columns. And this would be that. Now, before I finish, I want to mention that we already have videos talking about the design of foundations, but those videos are basically one foundation at a time. This is a structure, so one interesting part of the structure is to notice that here you would have a foundation looking like an L shape, and you have to force the foundation to look like an L shape, and this is something I want to do next time. As for the design of the members, I'll just mention very quickly right now that you can easily make a trial and error system here because the size seems to be big. I think I know that I have oversized them. So what I would do is the following. When I design a structure, when I analyze a structure, I use my rules of thumb to basically predict the sections of the structure. Then usually my sections are bigger than what I need. So then starts a trial and error cycle. You see, what I do is I have a section, I run the design, I get a ridiculously low steel ratio, so I know that my section is over-designed. So what I do is I make my section smaller, and then I design again. I keep making smaller and redesigning, until I start seeing that the steel is increasing a tad bit above the minimum. So now I realize that, okay, my concrete alone now is unable to hold the vertical forces, the gravity forces. I'm talking about a column now. I would know that my concrete of the column is not enough to hold the gravitational loads. In that case, he started to take steel. And that's where I will call it a day. As for the beams, it's a tad different, because changing the section of a beam also changes the loads or the moments are transferred on the column. You see, you should have a strong column, weak beam scenario, where the column is stronger than the beam this is basically one design concept that was not done in Turkey, and we all know what happened during that earthquake. I have covered it on the top right. Check that video out. But the beams is a little bit different. I need to make it a little bit weaker than the column. And the controlling factor for my beam design in my iterative scheme is to make sure that I am not going over the deflection ratio. As for the shear walls, this is where I personally am a little bit generous. In the shear walls, I think that those are one of the most important elements in the structure. So I usually am a little bit okay if I over-design shear walls a little bit, because it gives the stability of the structure, and it really is a good investment in that case. So this is how I would design it, and I have design videos about columns and beams and so on. You should check out the top right. I'm going to link them above. But what I want to do is actually I want to focus on the foundation in the next video, because it's interesting, because the video I have on my channel just deals with the foundation as an abstract concept. I have a foundation, there is loads, I need to design it. But here the foundation is kind of restricted. I have some restrictions in space, I have some restrictions in location, and I would have to have an L shape. Sometimes I would have to have a combined footing, wall footing. So there is really interesting concepts I want to cover here, and that's what I would be doing next time. Now, with that being said, I'm very happy, and I'm also happy to announce that we are going to start a bridge series very soon. I am really thrilled to announce that, and I'm looking forward to cover that in a way similar to the warehouse design series, because there is a lot of theory I need to flush out. It's different than reinforced concrete building design. I believe that most of our civil engineers do possess the theory that is needed here. It's not a special application, reinforced concrete design, but bridge design is a special application and it needs to be flushed out, and I'm planning to do that. So yeah, that's everything I wanted to talk about today. I hope you enjoyed. And with that being said, and before I finish, I want to give a huge bridge-sized shout out to my dear channel members in the contributor level and the helper level, whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos on time, hopefully, well, in the new year, that's my resolution, and with a certain quality I try to achieve, and for that I am forever thankful. Of course, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed it, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.